slope has implications in life, you know, like, I don't think anyone wants to go, like, drive down a hill that has a slope that looks like this. That'd be pretty bad, in either direction, by the way. You know, and I personally wouldn't want to climb a slope that looks even like this. So slopeness, a slope is really the steepness of a line. And of course, they can go upwards, like this one, we would say it goes up because we look from left to right. Of course, they can go downwards as well, which again would be down from left to right, okay? But they can be straight up like this one. I know that's not straight up because my drawing sucked, but they can be pretty flat like this one too, okay? And that's the kind of slope I like to climb. All right, so here we got 3 different staircases with some measurements, right? This would be a profile of a staircase. Why the crap are we looking at staircases? Because if you can understand a staircase, you can understand slope in any context, okay? Like this one, let's say which of the 3 staircases would be the steepest and why. So we look at this one, staircase 1, for example, here, it goes up 5 and then over 5, okay? So that's, I mean, not that we're worried about degrees, but it's pretty even upwards and over kind of thing. Now, this next staircase, up 3 and then to the right 8, okay? Now, some people mistakenly say this one is the steepest because of the 8 inches right there. No, it's not just the flat portion of the stair that determines its steepness, right? And that's where this 3rd staircase comes in, which say, look, goes up 6 inches and then 4 inches over, specifically to the right, by the way, which will be important. So this staircase, and some people start adding the 2 numbers together. It's really a ratio of height and then length, like this, okay? So if you look at this one, this is in red there, we got a 5-to-5 ratio, which, yeah, I mean, you could simplify it to a 1-to-1 ratio, right? 1-to-1. And then in purple there, that one can be simplified. You could say up 3 and to the right 8, 3-to-8 ratio kind of thing. And then in green, you could say it's a 6-to-4 ratio, which could simplify as well into a 3-to-2 ratio. And so maybe it's even better to see these as fractions, right? 1, then 3/8, and then 3/2. Well, the one with the higher value in terms of height to length here tells us which one is the steepest, okay? So a 6-to-4 ratio, staircase 3, that's going to be our steepest staircase because as a ratio of height to length here, it has the highest value. Now be careful because, again, some people would say, well, look at this staircase and let's make a determination here. What about a 9-inch to 10-inch ratio? And some people say, again, well, this one's steeper because of the 9 inches or even the 10 inches. Well, no, it's not any one individual value that you have to compare. It has to be compared with both, right? Say 9 to 10 ratio, which is, it's not even as steep as this staircase 1, even though the numbers are bigger, okay? So we look at stair steps like this, and yeah, I just Googled some pictures. But you got some staircases, you know, which one would you want to climb? Yeah, it sounds like you may have this one in your basement right there. And heights are not my thing, so like I don't think I'd ever make it up this high on a staircase like this. But if you got to climb it like you're climbing, like rock climbing, that's just, I'm not going to do it. But you can see, of course, that this staircase right here is very, very, very steep, unless the picture is just, you know, being manipulated in some way. This staircase, again, it was just taken off the internet, and it hasn't been altered except for it's just bigger than what I saw. So I'd say, yeah, this, you can see it goes up, and then there's a very small landing for your foot there, which makes it steep, okay? And then this one, we can see the landing is long, where the height of the step is very short. So if you looked at these 3 staircases, I'd say this one is the least steep, and probably the one I'd be most likely to climb, even though I probably wouldn't climb it. But and so where does this come into play for us mathematically? Is there's a couple different ways to look at it, okay? So it's look at this staircase right here. You got these endpoints on the steps. I know that's not a straight line. I assume that's because the steps are jacked up, but see if I can do that a little bit better. You know, something like this. And then these stair steps, you know, you can connect the noses of the stairs this way to create an actual straight line And so we're going to expect to see stair steps on the graphs that we make eventually. Like this one, okay? Find the slope of the line, and we'll enter the answer as an integer or reduced fraction in the form a over b. So first thing we got to do is find actual values on the line, which means at, and let's see if I can zoom in here. So some students mistakenly look at this ordered pair right here. What is that? Negative 4, 1, which is, being deliberate here, this ordered pair, okay? Negative 4, 1. And say, hey, look, that red line goes through that ordered pair. Well, it doesn't. It doesn't go through that ordered pair. It's very close, but it doesn't go exactly through it. And that's what you got to do. You have to look through the whole line. You know, you follow it all the way across, and you look for where it goes exactly through a grid corner, or again, if you look at this as like streets, it'd be an actual intersection. Yep, exactly like 0, 4 right here. Okay, that goes exactly through. If I scan this myself, I'd look at negative 5, 0. And again, you got some very close calls right here, like this one. And depending on the printing as well, that can throw you off a little bit. So you got to be careful with the points that you choose. But this printing, you know, again, is electronic, so it looks like it's pretty good. Now that we've identified 2 points, because that's all you need for a straight line to find the slope is 2 points. Okay, and we found them. In fact, you know what? I'll go and label these negative 5, 0, and then 4, 0. If we remember right, which I hope that we do, negative 5, 0 is the x-intercept. So there goes 0, 4, and that would be the y-intercept right there, okay? Now, you don't have to find intercepts, x-intercepts and y-intercepts to find the slope. You just need any 2 points that would be on the line. And again, for our specific example here, these are the only 2 points that I can find where there's no fractions or decimals in the ordered pair. So I'm going to create a stair step like this. See if we can. So I can see, and I always start with the point furthest to the left and then go to the one to the right. Now again, these are like streets, so I have to stay on the grid. So I'd have to go up. And I see that I go up. How far did I go up? Well, starting at this point, I would go up, and I count lines. So I start here, 0, 1, 2, 3, 4. So I went up 4. Some students choose to count boxes, and that'd be fine too. Up 1, 2, 3, 4. See that? However you do it, just make sure you get 4 on that, because some students say, hey, look, there's 1 right there. Nope, that's where you start. You start with 0, okay? 0, 1, 2, 3, 4. But then from that intersection, you'd still have to go to the right. Well, let's see how far to the right we have to go. Again, I start with this line, 1, 2, 3, 4, 5. And again, some of you may count the boxes, 1, 2, 3, 4, 5. As long as you get 5, that's what we need, okay? So what do we do with slope? Well, slope is also known as rise. I'm sure some of you guys have heard of this, rise over run. Not the runs. So the rise on this one, see how it goes up 4? So that'd be up 4, and then to the right 5. Okay. Okay, so these both these values are positive. And it's written pretty much the same way that we saw those stair steps that we did before. Remember, it's up or down? Well, up, I guess. And then it's a ratio. It's just this ratio we're showing these as fractions, which it told us to do. But direction is important on these, because for the upwards, that makes it positive, and then to the right is positive when you look at run, okay? All right, now if by chance, for some reason you had to go down, then that would be in the negative direction. Or if by chance you had to go to the left, that would be also the negative direction. Now, since I always go from left to right, that means for me anyways, my denominators will always be positive, because I'm choosing always to go from left to right. Some people say, well, Sal, I'd like to go down and then to the left. Okay, then you'd have negative 4 over negative 5. Which makes, if you simplify that, positive 4/5. Okay, so either way that you do it, you need to get the same answer here as 4/5. Yeah, so, and this is the beauty of straight lines here, is that the slope is going to be the same no matter if you go down and to the left or up and to the right, or in the future you may have to go down and to the right or up and to the right, something like that, okay? The slope, remember it's steepness? So look at this straight line. The steepness is never changing no matter what 2 points you choose. It will always have the same steepness. So direction, while it is important when we figure out the numerical answer, ultimately in the end, it won't matter because you'll end up with the same value. So here's this one, right? So we're looking at slope, which again is rise over run. Or, well, let's look at rise over run here, okay? So rise over run. And just to clarify on this stuff, okay? Rise is either up or down. Down being negative, up being positive. Over run, which is right, it's got to be either right or left. Okay, and right would be the positive direction for run, and then left would be the negative direction for run. But again, like I said before, I choose to always go to the right, no matter what. No matter what, okay? Again, you don't have to. Your slope should be the same no matter what 2 points you choose. So let's look at this one. On this graph, we just have to figure out 2 points to start with, right? So I'd say there's actually 3 different points we can start with. Looks like we got negative 5, 0. And then this point right here at 0, negative 2. But also, and this one is kind of on the edge there, but it hopefully is noticeable that 5, negative 4 would do as well, okay? Now, as we go through this, like right now we're drawing our stair steps, but you'll keep in mind in the future they're not going to give us any graph at all. They're just going to give us ordered pairs. And so we need to formulate, and we will formulate, a way to actually figure out the slope without any graph whatsoever, okay? So here we have 3 different points to choose from, but we only need 2, okay? Now, I'm going to purposely choose the 2 on the end, which means I'm ignoring the y-intercept. But even if you chose the y-intercept, you should get the same slope because straight lines have the same slope throughout, no matter what, okay? So let's look at the stair step on this one. So let's just identify where we'd need to go, right? So I'm going from left to right, so I'd say I'd go down first, and then I'd stop at this street, and then I'd have to take, I guess it'd be a left turn there. And then we'll go over here. So that kind of formulates the stair step. Now, this is only one stair step. You could have said, hey, look at my 2 stair steps like this. Okay. That's fine, but I'm only going to have this one here because I only want 1 rise and 1 run, okay? So rise over run, let's look at our fraction then. So set this up as a fraction. And I can see right away that from this street here down, I'd have to go down, well, how far down would I have to go? Well, for me, that's 1, 2, 3, 4 lines. Again, if you count boxes, that's fine. But down 4, down is the negative direction, so this 4 is going to be a negative. And then from there, you'd have to go to the right. Pretty far, by the way, but how far is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'd have to go to the right 10 streets. Again, that's to the right, which makes the 10 a positive. I'll show the positive sign now, although in the future I don't usually do that. Can this be simplified? Of course it can. These are both divisible by 2, which I will do. Negative 4 divided by 2 is negative 2, and 10 divided by 2 is 5. That looks simplified to me, and so we'll box that in. That is our slope. And so is it possible to see down 2 to the right 5, which is what I have in orange would indicate? Yeah, down 2 to the right 5. There's that stair step. Down 2 to the right 5. There's that one too. Okay. It's just we chose the bigger stair step, which in the end was able to be simplified into those smaller green stair steps. So yeah, that again, can a slope be just a regular whole value like 2, for example? Yeah, because you can make any integer like this, even though it doesn't look like a fraction, there's always that phantom divide by 1 there. And, you know, that's what makes the phantom value so creepy, is they're there lurking in the shadows, always watching. But now we want to show it, right? So this would be the same as going up to and then to the right 1. From whatever point, right? Like if you said, hey, look, start from this point right here, then you'd go up to, sorry, that's kind of small, but I think I can fit it, up to the right 1, and then that would be your next point right there. And then, of course, you could continue this pattern, making a stair step stair steps for you. All right, here's a unique scenario that we always tend to see, not just on the homeworks, but on quizzes and tests, okay? And we did talk about this, the steepness of this line when we introduced the lesson, right? I mean, think about the lines we just saw, right? Like the one that was just like, kind of like this. I mean, hey, that's pretty good if you wanted to go sledding. That sounds pretty good, right? Or even the first one up here is like, yeah, I mean, you could climb that, you'd say. But it's like, do you really want to sled down this one? Maybe you do. Hopefully you have more equipment than just a sled, though. But let's look. Rise over run, okay? So choose to any 2 points. This one has 21 points for us to choose from. So, but we only need 2, okay? So what the heck? I'll choose this one at, looks like -8.5. And then I will also choose this point right here at, what the heck, -8, -8. Now, I think some of you know where this is going because the x values match. But whatever the case is, let's go ahead and find our slope. Now, on this one, I can see that all I am I can't go to the right or the left, for that matter. I always start with up or down, though, so let's do that. So I'm going to go down here. How far down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I went down 13. Which is my numerator, that would be down 13. So it's not just 13. Down means it's -13. And then I can't go to the right or the left, for that matter, which means that, I mean, you could say at this point to the right 0. You can say to the left 0. It's the same thing. It's just 0. You're not going to go anywhere at this point, okay? Now, hopefully we understand what it means. When the denominator of a fraction is 0, it just means it's undefined. I believe on the homework it's one of those D&E type situations. This is, and again, that does not exist. It's more that the value is so large that it's undefined, right? It's infinity. We use it in life. But in any case, all right, if you ever see a 0 denominator, it's automatically an infinite slope, which again, it's the steepest slope we can find. And again, this goes back to the analogy of just sliding down this thing. It's may not end very well. Now, if this line has the steepest slope we can find, mathematically speaking, and think about how this would work if we asked you for the smallest amount of slope that you can have, and think about what that line would look like, okay? Even though we kind of went over it, but not explicitly. All right, given these points. And we got to find the slope. We'll write the answer as a fraction. So there's a couple different ways to do this. Most students like the formal way. But think about what we were doing in those last examples, okay? And how we were finding the value of rise and run, okay? And of course, the 2 x values are directly related, but also the 2 y values are directly related as well, okay? Remember, y's are kind of the up and down number line, whereas x values are the horizontal number line, okay, which indicates run. And we know that slope is always rise over run, okay? So how are we finding how far it is from one to the other? Well, you could say on a number line, you'd start at 4, and then since I'm looking at the y values, it'd be up to 6. So in this case, you'd say you'd go up 2, right? Which indicates that the rise is +2. Or from 1 to -2. Now, 1, you'd have to go down to get to the negatives. That's just how far down? Well, you go down to 0, then -1, then -2. That says down 3, so that makes that denominator, or the run. I said down, I should have said to the left. Skip that downward action, just right left. So left 3, which makes it -3. So I'll just say left 3, which again makes this a negative right there. That is one way to do it, and this fraction would be considered fully simplified. Some people would say it's not simplified till you see the negative out front in front of the fraction. All right, I think Canvas will accept either one of these, by the way. But yeah, it can't be simplified any further, even if you wanted to change it to decimal, same value. But yeah, I did say to write it as a fraction. So let's formalize this just a little bit more, okay? Although I'm still going to use what I call a rainbow method, which I prefer. on these ones because we got some, right? We got the rainbows with the Y's and we got the rainbow for the X's right here, okay? And so there's my fraction. And so, again, from -9 to 4, you could say you're going to go from -9 to 4, which would be fine, but it's distance, isn't it? Okay, so you're saying you're going to go from -9 to 4. That's distance. And how do we calculate distance mathematically? It's a difference, which means really what I'm going to do is take these two values, -9 and 4, and subtract them. That tells us, now -9 minus 4 is, they're 13 apart, but in this case you'd say even from 4 down to -9, which makes that -13, okay? Again, the minus here indicates a difference or a distance between the two values. But I'm going to do the same thing with the x values. So I'm going to go from 15 to 10. What's the distance there? 15 minus 10, boom, 5. So that'd be my denominator there. Now, if this fraction could be reduced, I would, but it can't. Some people would say you got to change that into a mixed number. Nope, we don't. In fact, for slope, we don't want to see mixed numbers because this is more explicit with the rise and the run. This is down 13 and to the right 5. It has a slope of a little bit more than -2, I guess -2.6, to be technical, but whatever. And that is where this formula comes from. Slope formula. Perhaps you've seen this before. I assume you didn't want to because most people have bad memories of it. Whatever, okay, so we've got to deal with it now. Now you're going to see these values, y's and y's, y1, y2, x1, x2. Some people change these, y2 minus y1 and x2 minus x1, okay? It doesn't matter. It doesn't matter. All right, so think about it like this. If you look at a graph, you have 2 points on a graph. Doesn't matter where they are, what quadrants they're in, none of that matters, okay? You just got 2 points like this. All right? Now, the slope is the steepness of the line. So if I wanted to go from the purple point to the green point, that will have the same slope as if I had gone from the green point down to the purple point like this, right? Which is why when you're plugging in the ordered pairs into this formula right here, it doesn't matter which ones you choose first or second. See, it's not going to matter. And I'll show that, I think, in the first example here. So let's write the formula out and then fill it out as we go. Okay, so we got, I said it was y1 minus y2. Again, it doesn't matter. Over x1 minus x2. You know what, I'll color code these. See, doesn't that color make your heart feel really good inside? Well, on this, for the first set here, I'm going to say that this is my first point, 15, 5. So that'd be x1, and that's y1 right there. So I now go into the formula and replace the y value with the y value from that ordered pair is 5. And then I replace the x value with the x value in that same ordered pair, 15, okay? This is crucial that you understand that up and down, we create an ordered pair. It's just the y values on top, okay? And then for the second ordered pair, I'll say my x2 is 4 and my y2 is 8. So let's replace that y value, y2, with the y value in that ordered pair, which is 8. And then the x2 value with the x2 value from the ordered pair, which is 4. And hopefully that color coding helps. Now, I know some of you would do that in your head, and you can do that pretty well, but the calculator will do this for you if you need it to, okay? So remember, you got, well, I got to turn it on, but you push the N over D button first, right here, and then in the numerator, you just type in 5 minus 8. You can see that it shows 5 minus 8 in the calculator. Now go to the denominator, type in 15 minus 4, and when you push enter, this calculator here is going to simplify it for you. I push enter. It shows the slope here as -3/11. So I'm going to switch those up, okay? So I'm going to say that the second ordered pair, I'm going to do that first, right? Now notice that the 8 is still on the numerator and the 4 in the denominator there. And then also the 5 and 15 still top and bottom. But it has to be aligned with this ordered pair, okay? Now, again, just go to your calculator, plug this in, let's see what we get, okay? So N over D, 8 minus 5, all over 4 minus 15, boom, -3/11. So see, again, doesn't matter which order you put these numbers in, As long as you have ordered pairs above and below each other, like we have here, it gives you the same slope because the slope of the line isn't going to matter what direction you go, the slope will stay the same. Now, you'll see on this one with the negative slope, if you were to put this on a graph, and I'm not saying we are, but if you were to put this on a graph, it would look something like this. Negative slopes, whenever you see a negative sign with the slope, it indicates that it's going down from left to right. I think I said that earlier, but I want to emphasize that again. All right, determine the slope of the line goes through these 2 points. Why don't you guys take a minute, try this one out, okay? Then we'll go over it. Let's do the work here, though. Okay, so again, I'm going to say that this is x1, y1, right? So let's go and replace those values into the formula. So the x value there is 6, and then the y value correspondingly is 5. And then we got our second order pair, x2 and y2. So replace your x value or y value first. Just make sure they're placed correctly. So the x value here is -6, and the y value is -1, okay? So, let's see. Well, you can put this into the calculator. I guess I'm doing it in my head because it's a keep change thing, so that'd be 6/12. I think I said -1/2, but it looks like it's positive. Simplify those by dividing by 6. Yeah, 1/2. Yeah, so now could you just type this into the calculator the way that we had it? Of course you could. And it would have given you the simplified fraction right away, and you'd have even skipped the 6/12 right there. All right, what about slope and equation? So we have what we call standard form. I know this is kind of the first time we're seeing it in this class. You may be slightly familiar with these. Standard form, my suggestion here is that you kind of skip this garbage. Because if we ever look for slope in standard form, what we end up doing is changing it into slope-intercept form, okay? So y equals mx plus b is very common mathematically speaking. If you go to a math person and say, I don't know what y equals mx plus b is, they might freak out or laugh, depending on what kind of nerd they are. But for these, okay, if you see m, and this should come as no surprise, m stands for slope. Why? That should, but it's surprising though. No, it shouldn't be surprising because mathematically, it shouldn't make a lot of sense right here, okay? Right? We want to, as math people, we want to make ourselves look as smart as possible. So we kind of, if we said use S right there, it would make too much sense. You know what I'm saying? So M stands for slope. Why does it stand for slope? I actually don't know. I kind of assume the Greek word for slope starts with an M, but I can't prove that. And I really don't care to prove it. The B in this formula here is the y-intercept, where remember the y-intercept is where the x value is 0, and then you find your corresponding y value right there, okay? Now, if we know the value of b, which again should be a number in the equation, then you'd put that into your ordered pair with your y-intercept. Now, something to keep in mind is that the x and y values, they're the variables, which means that there's an infinite number of values of x and y that should be able to make that true, which we have seen before. Even though in this section we're looking at only 2 values that really make it true. Okay. There's something called point slope formula, but they use the same m for their slope, which I don't know if we'll see that today, but maybe eventually we will. Right now we're really concerned with slope. Okay. Now again, we're going to look at changing standard form into slope-intercept form manually, which will then tell us the slope and the y-intercept. So let's look at just an old-fashioned equation. Y equals, let's say, -3/2 x plus 5 right here. And they said, hey, find the slope. Well, it's the slope is the coefficient of x in this formula. Even if it's a fraction, yeah, that's okay. The slope here on this one would be -3/2. Now the y-intercept, this is where things get a little tricky, right? I can see what I'm adding to the x's. So this is the y-intercept. And then some students would say, hey, look, my y-intercept right here, I know right here, just from this equation, that it's 5. Now, that's partially true. Just remember, and I've said this before, when you write a y-intercept, especially on an exam, you should be using an ordered pair for that y-intercept. If you don't, then I have to take a point off, okay? So make sure you show it as an ordered pair, 0, and then the number. Remember, 0, the x value being 0 is what forces that to be a y-intercept on the graph. So I kind of spilled the whole jar of beans right here, but this formula right here is how you can find the y-intercept if you do not have it. But we won't be able to cover that today, I don't think. So yeah, look at this one right here. Write your numerical answers as whole numbers or reduced fractions. And again, this is important. We want to write the intercepts, specifically the y-intercept, which is what it's asking for here, as an ordered pair. Now you could say B is your y-intercept. Some people, again, just say y-intercept like this, whatever. It's the same thing, just for as long as you put it into an ordered pair format. So on an equation like this one, and I'm kind of purposely starting with the y-intercept because this is where a lot of the deception occurs. Some students say, look, I found the 7 right there. That is my y-intercept. As a term, though, it's considered -7 from the minus sign. Make sure you don't forget that negative with your y-intercept on these. Okay, and I think the slope was the easier of the two. This one, yeah, just -8. That would do. If it needed to be a fraction like we saw on the last slide, then you can write it that way. Some people may even write -8/1. Like if you had to graph it, okay, that's fine, but we don't need to. Just -8 will work. Yeah, now, of course, we should ask the question, why are we not seeing the x-intercept right now, where in the last section we saw a lot of x-intercept and y-intercept stuff? It's because what this is leading to is getting us to be able to graph these equations, and the only two things you ever need is not just the y-intercept, you just need any point that would make the equation true, and then also the slope. If you can have those two things, you can graph any line. At least any straight line, I should say. Now, having said that, though, you'll keep in mind that when lines are no longer straight, a table is pretty much the main method for graphing lines that are not straight anymore. Which I think we'll get to that in this class too. I guess I should have remembered the slope is the coefficient of x. Be careful because again, in the past, students had said the slope is -8x. Boom, -1 point there. I see that you get the -8 thing, but the x, that's not a slope. That is a variable, not a slope. All right, here we go. Let's give ourselves some space here. Let's write this out. And yes, intercept is a very long word for me, so I'm not going to spell it all out. And just to make sure I don't forget to put this in an ordered pair, I'm going to put the 0 in the parentheses in the column there for my y-intercept, okay? So on the last one, we did the y-intercept first. Doesn't matter which one you do first. I'm going to start with the slope on this one just to show that it doesn't matter. The slope is the coefficient of x, which in this case is -7. Again, please do not put -7x, otherwise you'd lose points. And then the y-intercept, I've already got my ordered pair set up. There it is. That's what I see what that's adding there, the 2/5. Yeah, and it's okay if that's a fraction in there. All right, so this one, I think we're getting closer to that question right here on this one. But we do need the slope and y-intercept. Yeah, so there I got my y-intercept set up. Now this one, the slope is easier. It's just the coefficient of x. There it is, -11. Okay. So again, as a actual slope, if you were graphing this, you'd say down 11, and then you got the phantom divided by 1 there. Down 11 to the right 1. We don't care though. We just want to identify the slope. Now, some of you, I think you understand what is being added to that -11x. It's a phantom plus 0, which we've seen quite a bit, especially with solving equations, right, with principles of equality. Well, there we kind of see a need for seeing this phantom plus 0. And so the y value being 0, that's the origin. And so equations that look like this, this is also the equation for a proportional equation, not that I think anyone cares. But whenever you see that there's nothing being added or subtracted to your x's, it looks like this, then it goes through the origin. So I'll do this one a little differently, okay? So remember, it sets up, this is slope-intercept form, which is very nice. It always sets up as y equals mx plus b, okay? So remember, the slope is m, and the y-intercept is b. And again, I don't know why the y-intercept is b either, but whatever. And I'll set my y-intercept up with an ordered pair, like this. Well, I can see that the m is the coefficient of x, and 7/11 is the coefficient of x. So that is the slope. Again, that would read up 7 to the right 11. And then the b value, the positive 24, is in that position. And it's positive because of the plus sign there. So 7/11, 24. Wonder if there's hidden meaning in that, but whatever. All right, so we got numerical answers. Yeah. So, and this is the first time we've seen this. If the y-intercept does not exist, D&E. All right, fair enough. I guess we could say the same thing for the slope as well. In any case, we should look at this equation, y equals -957. Now, I purposely gave myself some space there because there is a phantom zero, not just zero though, it's a 0x. Yeah, so this would indicate right here that the slope, m, is 0. Okay, there's that phantom 0. Well, yeah, why can we put the x with the 0? Because anything times 0 is 0. So you're welcome to put whatever you want there. I just want to see y equals mx plus b. So there it is. And then the y-intercept, well, again, remember to put this into ordered pair format. And it's a big number. Hopefully that doesn't really make a difference right here. Yeah, I was just showing this 0x here so that if you need to visibly see the slope, you can. But yeah, that's a negative 957 as our negative 957 as the y-intercept. Okay, so yeah, that's the first time we see that. And again, this slope right here, think about what this would look like on a graph, even though we'll see it later. All right, this one's interesting, okay? And it may be helpful to see what this looks like. We've seen this before, but think about what this looks like on a graph, okay? So the only value that would make this true is an x value, and it always has to be negative 2/5, right? So you say negative 2/5, negative 2/5, negative 2/5. The question here is, since we want a y-intercept, can I make x 0? Question mark? No, I can't do that because then it would make this original equation a false statement. You can't do that, okay? So I can't do that, which means that there is no y-intercept. So when I say y-intercept here, again, it says to put DNE, no problem. Does not exist. In other words, this line, if you were to graph it, is never going to cross the y-axis. Not anywhere, not ever. But can we find the slope? All right, well, I suppose we can. So let's look at some y values, like 1 or 2 or negative 80 or 57.631. I don't know, something like this, okay? Now, if we wanted to find the slope, you could even use the slope formula. I'm purposely making this probably longer than it should, but to prove a point, okay? So let's start with this ordered pair, okay? So I'd say y is 1, x is negative 2/5. Fair enough. All right, then we'll make this ordered pair the second one. So that's y value of 2, and the x value is negative 2/5. Now, if you put this in the calculator, it's going to give you some kind of divide by 0 error, which indicates that it's one of those DNE types. The denominator is going to be 0 is what's going to happen right there. It's an infinite slope, which, again, for a problem like this one, we're just going to put DNE. So, just to emphasize what's happening here, if you were to look at the graph, x equals negative 2/5. Yeah, so it'd be something like this. Or pretend like I can draw straight lines here. But, yeah, you can see that this slope is infinite. It's a straight up and down line. So if you ever see an x equals and there's no y's, yeah, there's not going to be a y-intercept. It's just straight up and down line. All right, so here's our equation. This one is the first one we see with standard form for a linear equation. Well, we can work with this. All right, so let's take a look. So I'm going to work with this equation. What I'm going to do with this equation here is I'm going to solve for y. This goes back to 110, I think. Okay, where I'm going to manipulate this equation until it needs in the end to just equal y. Y equals something. And then it should be in the form y equals mx plus b. So for me, I'd say I'd have to isolate my negative 12y's, so I'd have to add 6x's to both sides. Now I put the plus 6x right underneath the 48. Some people like to stagger that because they are not like terms 2 combined, right? It's just, I like to put it right under the 48 because I do want the x term to be first. So that's positive 6x and then a positive 48. Again, these are not like terms that you can combine, but it will zero out my negative 6x's. I will drop my negative 12y's, which now equals 6x plus 48. This is already starting to look like y equals mx plus b. It's just, we don't want the negative 12 coefficient of y. So we can zero that out, though, by dividing all the terms, and you do have to do it with all the terms, by negative 12, okay? So that becomes the phantom 1y, which is what we wanted. This is now solved for y. And then the slope here, I see 6 divided by negative 12, which would be negative 1/2. That's how many x's there are. And then 48 divided by negative 12 is negative 4. This then allows me to identify the slope and y-intercept because it is in slope-intercept form. So there's the kicker on that. Slope-intercept is not just any intercept, it's the y-intercept. And as long as you can put it into that slope-intercept form, you will always have your slope and your y-intercept. So the slope in this case is a fraction, down 1 to the right 2, what I'd say. And then the y-intercept is at 0, -4. Again, if you were to need to graph this, you would do the y-intercept first, and then you'd use the slope to find all of the other points on the graph. Now, the equations look different. It's -6x minus 12y equals 48, and then we had y equals -1/2 x minus 4. These are the same equations, they just look different, that's all. Kind of like what we have done with fractions. You can do the same thing with equations, and I guess we saw a lot of that in 110, right? All right, so parallel and perpendicular lines. You're going to see questions like this on the homework, not only for today's homework, but I think in 3-7 as well. So that'd be Thursday. Parallel lines, they're going to have the same exact slope. So, and hopefully this kind of makes sense, right? Like, and again, we're pretending like my lines are exactly straight. Well, these are the axes. Yeah, both of those would need to be true. Some people would say that the second one doesn't necessarily need to be true. It's just, then they'd be the same line, and you could say they're parallel, but parallel usually means that they don't actually intersect. So if the y-intercepts are the same, that means that they intersect everywhere, which some people would say is not parallel, whatever. So parallel lines, right? So let's see, like visually you can see, again, well, dang it. I think that's about as good as I'm going to get on that, but if we pretend like I drew very nice lines, you'd say, look, the slope here on the purple and the red lines is the same because the steepness is the same for both lines. And steepness is the slope. But you can see as well that they go through the y-axis at different points, which in slope-intercept is crucial. Slope-intercept form, okay? Now, perpendicular lines. I'll demonstrate this, although with words it's kind of hard to just straight explain. So, for perpendicular lines, perpendicular means 90 degrees. So if you looked at a line like this one, a perpendicular line, we'll pretend like that's 90 degrees right there. That's a 90-degree mark. But what happens with the slopes is that they are opposites and reciprocals. When we say opposites here, we're talking about positives and negatives. Those are opposites, okay? Which means you change the sign of the slope. Reciprocals, so if we look at let's look at reciprocals. A reciprocals is where you take a fraction like a over b and then you reciprocate it to be b over a. Okay, so you'll see the fraction flipped, but you'll also see the sign change as well. Now, if you had a slope that was just a regular number, again, let's go back to 2. If I wanted its opposite reciprocal, I would probably want to see the 2 as a fraction, meaning 2 over 1. So then when I reciprocated it, I would get 1 over 2. And where it used to be positive, it is now negative. So this would be the slope here would be the slope of a perpendicular line. Now notice that we don't really care about the y-intercepts because the slopes have changed now. So they'll always be at 90 degrees from each other, which is the definition of perpendicular. Yeah, that's true. I think some students prefer, instead of saying reciprocal, flipping the fraction. Yeah, that works too. All right, so we have this equation that's in standard form. A line parallel to the line above would have a slope of blank, and then we want to find the perpendicular slope as well. So let's look at this equation though, and then let's change it into slope-intercept form for us, okay? Then we can actually see the slope and also the y-intercept. But again, since I am changing this into slope-intercept form, it's the same as solving for y, okay? So that'd be y equals something, which means I don't want the 9x there with it. I want to isolate the 4y, so I'd have to subtract 9x's. And again, I like to put it right underneath that 12, even though I know they're not like terms 2 combined, okay? So this would leave me with, we'll say 4y. And again, I like to see the x term first, so that's why I kind of stack it that way. It's a negative 9x and a positive 12, so I show that as plus 12. And then I would divide all the terms by the coefficient of y. You have to be careful. I've seen this happen all the time. Almost one student every time during an exam will have to do this. And they either forget to divide here by 4 or here. You got to divide all the terms by the coefficient, okay? So that does leave me with just the y equals the slope now, negative 9 divided by 4. Just show that as negative 9/4. And then 12 divided by 4 would be positive 3 right there. Now that means that right here, I can see the slope already for this equation. And remember, a parallel slope will be the same. So I would just match the slope there is negative 9/4. Well, what about the perpendicular slope? Well, we got to take that negative 9/4 slope, and we have to reciprocate and opposite it. So where it was negative, I will now make it positive and then flip the fraction. So the perpendicular slope would be positive 4/9. All right, here's an equation. This isn't one is in standard form, so let's go ahead and take a look at this down here, then we'll work with it, okay? Now, if I can just figure out the slope of this equation by changing it into slope-intercept form, then finding the slopes for parallel and perpendicular lines will be very easy. So that means, once again, which we've seen, is just manipulating the equation, solving, I'll put solve specifically for y, okay? So that means that negative 3x, it needs to be zeroed out because I want to isolate my 4 y's there. So I'd add 3x, but I'd do it to both sides here. Now I have this 3x stacked with the negative 24, and the reason that is even though they're not like terms, I'm not going to look to combine them, but I will show them as separate terms. I just want the x term first, so it looks like in the end what we want, y equals mx plus b. And you see how the x term goes first there with y equals mx plus b. So there's my 3x, and then we also have the negative 24. I just can't combine them because they're not like terms. So that did zero out the negative 3x there. I'll drop my positive 4y, which now equals 3x minus 24. The last step here is to divide all the terms, not just one, but all the terms by 4. Don't forget to do it with all the terms. This will make the coefficient of y phantom 1, which is what we want. And we're left with y equals, I'll just show that as 3/4 x, which is my slope. And then negative 24 divided by 4 is negative 6. Now, the y-intercept for this question isn't important. What we really are concerned about here is the 3/4, which is also the slope, okay? And the reason why that's important is because a parallel line will have the same slope, so it would have a slope of 3/4. A perpendicular slope will have the opposite reciprocal, so we would take that 3/4. It's positive, so if I changed it into its perpendicular slope, it would then be a negative, and then we would flip that fraction into 4/3. So a perpendicular slope would be negative 4/3.